I'm going to be going over in this video for you how to represent graphs with slope-intercept equations. So, oh yeah, I forgot to mention, give this video a thumbs up, subscribe, comment below, all that fun stuff, because you know I'm a YouTuber. Here is the general format of how we would write a linear equation in slope-intercept form. So the y, it's always the variable, we keep it as a y. The m is the slope. The x, we also leave it as a variable. And the b is the y-intercept. So just to review a couple of these words with you, the slope means the rise over the run on a graph, or the rate of change. How much is the line on the graph increasing or decreasing? The y-intercept is the point on the line that crosses the y-axis. So if I have a quick sketch of a graph here, so here's a line. This point right here, it's where it crosses the y-axis. So this right here is the y-intercept. Here is an example of a graph that we could write an equation, a linear equation in slope-intercept form to represent. So in order to write this equation, I need to find two things. One, what is the slope, or the m? And two, what is the y-intercept, or the b? So what I need to do is I start with the y-intercept. So I look to see on this graph, where is the y-intercept? Where is it crossing this y-axis here? And the line crosses right here at this point when y is 1. So b equals 1, because this is the point where it crosses. Next, I find the slope. And in order to find slope of a graph, there are a couple ways to do it. One way I can find slope is by doing rise over run. And so what I need to do is find 2 points on the graph. And these 2 points should be exactly at the corner of a grid line like this. So we have many lines on the graph. And so when the graph crosses at a corner of one of them, it will be at an exact number. So here's what I mean by that. This point here, it's at the corner of this grid line and this grid line. And on this graph, there's many little ones. Let's just pay attention to the darker ones, because these are the whole numbers. This is a grid line at -1, -2, -3, 2, 1. So we're just going to ignore the faint grid lines. Just look at the major dark ones. So this point here crosses at the corner of this grid line and that grid line. So I'm going to look to see on my line, where does it cross at another corner of a grid line? Here's the x-axis, but I notice it's not at the corner of a grid line. It's kind of right between -1 and -2. I don't know exactly what it is though, so I'm going to keep going. And right here, I notice it's at the corner of this one and this one. So this is the other point that I can use, because I know that it is exactly at -3 on the x and exactly at -1 on the y. So now that I have 2 points picked out, I'm going to calculate the slope, or the rise over the run. So my rise, I need to go up 1, 2, and I'm increasing, so it's a +2 for my rise. And then the run, I need to go over 1, 2, 3 places. And I go to the right, so it is a +3. So my slope is 2/3. Every time on this line we go up 2, we go over 3. If we go up 2, we'd go over 3. And that's the rate of change on this line. It's how much it's increasing. So then I take these two here let me erase my grid line picture here, the m value and the b value, and I put them into my general equation, y equals mx plus b. So I keep the y equals m, now I know the m is 2/3, so I change m to 2/3 times x, plus b, we know now equals 1, so plus 1. And this is the equation that represents this line here. We aren't solving anything because we have two variables, so we can't solve to see what one equals. So this is your answer. We're writing an equation to represent the line in slope-intercept form. So that is how we would do this. Here is now one more example that we can go through together so you get a little more of an idea of how we do this. So in this case, the graph is similar, except now it is decreasing. So we're going to have a negative slope. But anyway, we're going to start off the same though with the y-intercept, so our b, and I see on the line it crosses the y-axis right here. So exactly at 1, when x is 0, y is 1. So the y-intercept is when y is 1. Now our m, or our slope, we're going to do rise over run. And in order to find the slope, I need 2 points on the line. So remember, we look for when this line crosses exactly at the corner of 2 of these dark grid lines. So when it's exactly on a number. So like here, for example, at this point on the line, it's exactly at 2, but it's not exactly at a number on the y-axis. It's not on the corner of a grid line, so I wouldn't pick it. So let's keep going down. Here's the x-intercept, but it's not at the corner of one of these grid lines, so we don't pick it. We're going to keep going down, 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 and we get right here, and we have the line crosses at the corner of these 2 grid lines. So this is the other point that I will pick. So now I have my 2 points, so I do my rise over run. So we always go from the left point to the right point. So we're going to go 1, 2, 3 down, and since I'm going down, my rise is negative 3. Then my run, I run 1, 2, 3, 4 places to the right. Since it's to the right, it's a positive 4. So then I take these numbers and I put them into my equation. Y equals m, our slope is negative 3/4, x plus our y-intercept, the b is 1. So this is the equation that shows this graph, this line on the graph right here. And that is how we write equations in slope-intercept form when you are given a graph.